Hey everyone, and welcome to today's Explainer. Today, we are going to explore how a single microscopic molecule is fundamentally changing exactly how and where the world gets its energy. To fully replace our century-old reliance on fossil fuels, we're going to need a truly mind-boggling amount of clean energy. And right now, we're watching the rapid rise of international green hydrogen trade step up to fill that massive void. It is an infrastructure shift on a scale we've basically never seen before, leveraging the most abundant element in the universe to redraw our entire global economy literally from the ground up. So let's dive right into this massive shift by looking at the incredibly high stakes of global energy geopolitics. What actually happens when a single molecule redraws the global energy map? Well, the short answer is a complete top-to-bottom transformation of international relations, trade networks, and heavy industry. For the last 100 years, our energy map was dictated by a geological lottery, right? It was just about wherever oil and gas happened to be buried. But now we're transitioning to a dynamic new map, one that's dictated entirely by renewable energy potential and highly strategic industrial alliances. And that brings us perfectly to our first core section, redrawing the global map. We are right in the middle of a massive transition where the energy territories of the past century are being completely rewritten through these strategic bilateral partnerships. Okay, so the crucial takeaway here is that these multi-decade supply agreements are giving birth to a highly active, totally high-stakes phenomenon that experts are calling hydrogen diplomacy. Picture this. You have resource-rich exporting nations, places with just insane amounts of untapped solar or wind potential, like Australia, Chile, or regions in North Africa. And they are sitting at the negotiating table with massive energy importing industrial economies, like Germany and Japan. Through hydrogen diplomacy, they're locking in binding bilateral trade partnerships. And you might be wondering, why the immense rush? Well, it's because these industrial economies are staring down some seriously steep decarbonization mandates. If they don't secure their supply of clean molecules right now, their heavy industries are basically going to starve in the 2030s. So it's an absolute gold rush to establish these secure, multi-decade supply agreements, because whoever secures the molecules now will dictate economic power for the next half-century. But as you can probably guess, redrawing the global energy map requires a whole lot more than just handshakes and diplomatic treaties. It requires some serious heavy machinery and cutting-edge science. So let's look at the physical mechanisms making this all possible in our next section, the technology behind the trade. Now, what's really fascinating here is that we're watching a massive billion-dollar technological face-off play out in real time. Right now, there are two commercially dominant water electrolysis technologies powering this entire transition. On one side, we have alkaline systems. Think of these guys as our highly reliable legacy marathon runners. Their absolute biggest advantage is that they offer significantly lower upfront capital costs, which, makes them incredibly attractive when you're trying to budget out a massive mega facility. But there's a pretty major engineering dilemma here. Green hydrogen relies entirely on renewable energy, and renewables are notoriously intermittent. The wind stops blowing or some clouds roll in and your power drops. This is where proton exchange membrane, or PEM electrolyzers, enter the arena. These are our agile sprinters. PEM electrolyzers provide superior dynamic flexibility. That means they can ramp their power consumption up and down in literally seconds to adapt seamlessly to those constantly fluctuating wind and solar generation profiles. So plant designers are constantly having to weigh the upfront financial savings of alkaline systems against the vital grid-saving adaptability of those PEM electrolyzers. Okay, moving on to our next section, let's see how this actually builds into the local ecosystem. Because handling all this newly generated power requires a massive grid upgrade at the local level. Upgrading the grid. So, transitioning to shore power is just a monumental engineering headache, and it requires a really strict three-step approach to keep everything running smoothly. Step 1 is utility collaboration. This demands deep, continuous cooperation between municipal electrical utilities, highly bureaucratic port authorities, and fast-moving private terminal operators. Just getting those three completely different groups on the same page is a logistical miracle in itself, honestly. Step 2 involves substation upgrades. We are talking about delivering megawatt-scale power here. To put that into perspective for you, a single large electrolyzer facility can consume as much electricity as a small city. You simply cannot just plug that kind of massive demand into a standard aging electrical grid. And that brings us to step 3, battery co-location. Because pulling megawatt-scale power instantaneously would literally cause massive brownouts in neighboring communities, these facilities are absolutely required to co-locate grid-scale battery storage right on site. Think of these giant batteries as electrical shock absorbers. They carefully balance the load so the surrounding city's lights actually stay on while the port turns out all that hydrogen. Finally, let's zoom back out to see where the geopolitics, the massive electrolyzers, and these complex grid upgrades all physically intersect. This is our final section, ports as green energy hubs. You see, hydrogen might be the lightest element in the universe, but moving it, that is a massive, heavy logistical nightmare. Transporting these molecules over long distances requires extreme compression or cryogenic cooling, which is just prohibitively expensive. And that is exactly why co-locating green hydrogen production directly alongside heavy industrial consumers near major ports is basically the ultimate cheat code for this new industry. Think about it. If the steel mill or the chemical plant is sitting right next door to the electrolyzer, you bypass the entire transportation nightmare completely. By bringing production and heavy consumption together, these integrated port hubs minimize molecule transport costs and entirely eliminate those complex supply chains. It creates these incredibly powerful demand-anchoring hubs where production instantly meets industrial consumption. And this geographic clustering brilliantly illustrates the complete closed-loop ecosystem that these megaports are providing for the future of global commerce. By clustering operations together like this, we unlock 3 massive localized ecosystem benefits. First up, we secure localized chemical feedstock consumption. So industries that desperately need hydrogen as a raw material, like massive fertilizer production plants, they get it piped right into their facilities with zero friction. Second, it creates an immediate hub for regional transport refueling. Just picture massive fleets of heavy-duty cargo trucks moving goods in and out of the port, all running totally silently on hydrogen fuel cells that were filled right at the source. And third, it establishes the necessary infrastructure for international maritime bunkering. Now, bunkering is really just maritime speak for fueling ships. The global shipping industry is under immense pressure to decarbonize right now, and these integrated ports will allow massive cargo vessels to refuel with green hydrogen or green ammonia exactly where they load their freight. It essentially becomes a perfectly self-sustaining, zero-emission ecosystem. So, when you look at it all together, from the sweeping international treaties of hydrogen diplomacy to the highly specific grid-saving battery chemistry sitting right on our docks, we are watching the foundation of a brand new global economy being poured in real time. The geographic, economic, and industrial maps of the 20th century are officially obsolete, which leaves us with one incredibly massive lingering thought. As our coastal ports physically transform into the new undeniable megahubs of global energy, who will step up to become the true superpowers of the hydrogen age? Thank you so much for joining me for this explainer. Keep your eyes on the ports, and I'll see you next time.